This is the problem on absolute zero, and it says a temperature of absolute zero occurs at negative 273.15 degrees Celsius. What is this temperature on the Fahrenheit scale? So Tc equals negative 273.15 degrees Celsius, and we're using the typical conversion. So Fahrenheit temperature equals 1.8 temperature in Celsius plus 32, and when you do that you come up with the absolute temperature in Fahrenheit for absolute zero, and it's going to be a large negative number. And if you wanted to, you could also convert either one of those numbers to the absolute temperature in kelvins. However, that one is being defined as 0 kelvins, or in the Rankine scale, TR, and that is also defined as 0 Rankine. We will be using absolute temperatures. These two are absolute temperatures. Later on, this is not okay. This means 0 kelvins, so absolute temperatures. Later on, when it's important that we avoid negative temperatures, and that's why we need these absolute temperature scales, which are either in kelvins or Rankine, and the Kelvin is associated with the Celsius because there is a simple subtraction or addition of the 273 degrees, and the Rankine is associated with the Fahrenheit because there is a simple subtraction or addition of 460 degrees. By the way, here I'm giving the answer way to this problem. Here you also see the conversion formulas, and as I said, 1.8 times the Celsius temperature plus 32, or if you go the other way around, subtract 32 first and then divide by 1.8. This one here, I would go through Celsius. If you go from kelvins to Fahrenheit, go first through the Celsius and then go to the Fahrenheit. I wouldn't advise doing this one here because you just have to memorize more or pay attention to more stuff. And then here's the simple Rankine compared to the Fahrenheit. These two here are related to that when we change the Celsius to or when we have temperature differences, then the Celsius temperature increase is the same as on the Kelvin scale, and the Rankine is similar to the Rankine, that when we increase with a certain Fahrenheit temperature, then we increase with the same Rankine temperature. That's because the temperature steps are the same for the Rankine and the Fahrenheit as well. They are the same for the Celsius and the Kelvin. That's what they're talking about here, where they talk about temperature intervals. 1 Fahrenheit degree is the same as 1 Rankine degree, or 1 Celsius degree is the same as 1 Kelvin. Another thing I wanted to look at here, now that we looked at, of course we cannot use this thermometer here because our temperature here of absolute zero is off the thermometer. Another thing I wanted to look at is that when we looked at positive temperatures, then the Fahrenheit is always larger than the Celsius, and now we've been looking at the lowest temperatures so far in the negative, and the Fahrenheit temperature is lower than the Celsius temperature, and that means they need to meet somewhere. And one way of looking at that, figuring that out, would be to do the algebra, writing this down here. So Tf equals 1.8 times Tc plus 32, and now is saying that, well, in order to figure out where they meet, so Tf meets Tc is that would be to say that the two are the same as far as the value is concerned. So I can just write down here TC, or I should write down here TC, do the algebra on this, and when I do the algebra, you may do that yourself, you come up with that temperature is negative 40 degrees Celsius. And indeed, when you take negative 40 degrees Celsius and you multiply with 1.8, you come up with negative 72. And when you add 32 to negative 72, you come up with negative 40 Fahrenheit. So, as I said earlier, in the positive, the Fahrenheit temperatures are larger than the Celsius temperatures, and in the far negative, the Fahrenheit temperatures are smaller than the Celsius temperatures, and that means they have to meet somewhere, and well, this is where they meet. Negative 40 Celsius, the same as negative 40 Fahrenheit. This was just, again, a footnote to this particular problem.